Hello, everyone, and welcome again to your channel, Math Made Easy. Today, I'm going to show you a way to find the determinant of a matrix. Uh, we, uh, we looked at how to find the determinant before for a 3 by 3 matrix, right? We used a method called the duplicate column method, if you remember, and we used it also in engineering. Today, I'm going to introduce another method that works for any size of a matrix with 1 point. You should know that we can only find determinants of square matrices. A matrix that is 2 by 2, 3 by 3, 4 by 4, n by n, which you cannot do by hand, but the idea is the same. Why do I say a square matrix? Meaning the number of rows equals the number of columns. Otherwise, you cannot do it. The duplicate column method only works for a 3 by 3, as I said. So let's take another 3 by 3 today, and then let's look at this method. It's called the cofactor. Let's see what the meaning of cofactor. I'm going to spend some time explaining these basic stuff first, and then really we'll go to an example. Okay. So, in fact, maybe we can come up with an example. Let's say matrix A is 6, 0, -3. I don't know if I should do one that, well, because some matrices, just by coincidence, their determinant is 0. And these are very important matrices. We call them singular matrices, okay? But otherwise, any other number would make it helpful in solving system of linear equations. Remember, we did the Gauss-Jordan elimination method in solving systems of linear equation, and that may become handy when you do linear algebra course. Let's make another 0, make it easy. So I can use the duplicate column method since it's 3 by 3, but the method I'm going to talk about, first of all, we are going to define something called the minor matrix. Minor, I'm going to write it minor. We usually refer to, so a minor of matrix A. We write it M of A, but I'm just writing the whole name so you understand what we are saying. The minor is so easy. The minor of any entry in the matrix. Let's say I want the minor of -1. So I'm going to hide the row as well as the column in which the -1 occurs, and then find the determinant of the resulting matrix. Notice now the resulting matrix is only 2 by 2. So I'm going to say 6 times 0 minus 0 times -3, which is 0. So, and I will enter a 0 here in the intersection of second row and third column. So easy. So let's find the minor of all of these. They are 9, but it doesn't take long. If we hide if you want the minor of the 6, you would say 3 minus 0 is 3, so I enter 3. I want the minor of the 0, so I hide the row and the column of the 0. I get 6 minus 3 is 3, again. If I want the minor of the -3, I would say 0 minus -3 is +3. So in fact, the first row is a bunch of 3's, okay? Let's do the 2. Hide the column and the row. Of course, if you have zeros, then it's 0, because you're going to say 0 times 3 minus 0. So 0. Oh my God. Let's do the minor of the 1. You get 6 times 3, 18, minus -3 times -3 is +9, so 18 minus 9 is 9. Let's find the minor of the -3. 0 minus -3, so that's +3. The minor of this 0 is -6, minus -6 is 0. And finally, the minor of the 3 is 6. Minus 0 is 6. So here is the matrix of minor. And finally, we are going to do, or to find, the matrix of cofactors. I'm going to write it with the letter C. We call it C of A, but let's say cofactor. And here it's so easy. I'm not going to do any more calculation. Don't worry. Don't worry. In fact, if you are experienced, you will go from here to here directly as I will show you. Here, next to those, I'm going to draw positive, negative, positive, negative, positive, negative, positive, negative, positive. What is that? The definition, I can write the definition for you. If I say C of ij, where I is the row number and j is the column number. So this number, for example, is C 3, 1. Third row, first column. C 2, 2. C 2, 3. C 1, 1, and so on and so forth, equals -1 raised to the power of I plus j times the minor of ij. So, what is that? Well, this is a -1 raised to a power. If the power is odd, meaning if the sum of the row and the column is odd, 1 and 2, 2 and 1, 2 and 3, 3 and 2, you change the sign of the minor and make it negative. If the sum is even, like 1, 1, 1, 3, 2, 2, 3, 1, 3, 3, -1 to any even power is +1. So the cofactor and the minor are the same. In fact, I'm going to, just circle these 4 digits because these are where the negatives are. And then the cross, the main diagonal and the other diagonal are where they stay the same. So 3, 3, 9, 3, 6 stays the same. There is no difference between minor and cofactor. But for the others, in fact, there are 3 zeros. So whether you say positive or -0, it's the same. And only the 3 becomes -3. So really, while you are working, every time you can circle these with a lightly with a pencil. And when you go here and you find the minor, change its sign, and you can go directly from here to here. Some other people do it slightly different, and you say, okay, we did all this work for what? To find the determinant of A. Now, for the determinant of A, you can expand. That's the word expansion. You can expand over any row or any column of your choice. What is that? What does that even mean? Expand. Expand meaning, I'm going to say, for example, expanding over, I'm going to expand either over the second row or the first or the second column. Why? Because there are zeros. So I don't even need, so let's say over the second row, the determinant of A equals second row. So I take the second row of the matrix and the second row of the cofactor and just multiply them. 2 by 0 is 0. 1 plus 9 is 9. -1 times 0 is 0. So the determinant is 9. Meaning, I could decide from the get-go that I'm going to expand, say, over the second column. Why? Because the second column has 2, 0. So all what I need to do is to find the minor of this number and multiply it by 1, meaning the minor of this number should be 9. And how do we do it? You're going to say, okay, what is the minor of this number? Let's hide row and column. 6 times 3 minus -3 times -3. It's 18 minus 9, it's 9. So the answer is 9. Sometimes they tell you expand a specific row or column, but here, if you say that, you get 9. Or, so in the second column, I'm say the magnitude of the determinant or the determinant of A is 0 times -3 plus 1 times 9 plus 0 times 0 equals 9. Someone else want to use expand over the first row. Some people always use the first row for some reason I never understood. So it becomes 6 times 3 plus 0, plus 0 times -3 plus negative 3 times 3. 18 minus 9 is 9, and so on and so forth. It doesn't matter. And this is the cofactor expansion method. Very simple. Hope you got it. The cofactor would help us later find the inverse of a matrix, as well as solving a system of linear equation with a method called Cramer's rule that I will go over shortly, maybe tomorrow. Thanks for your time. Hope you enjoyed that and understood the cofactor expansion and how easy it is to perform, especially for a 3 by 3. And hope to see you soon. Bye.